Okay, ladies and gentlemen, welcome to the first geometry YouTube video of the school year. This is to help you prepare for your sections 1, 2 through 1-5 quiz. Okay, so I'll go through several problems, and hopefully you'll feel confident coming into class on Thursday, or for my white block kids on Monday. Okay, so let's take a look at this first problem here. This problem says use the figure at the right for exercise 8 through 11. So, what are two other ways to name line EF? Well, if I look at this picture, line EF, here's E, here's F, so there's the line EF right there. Okay? And two other names to name that, so we'll put a little 8 there, would be any of the three letters. Use two of them. So I could call it line EB with the line across the top. I could use BF, I could use FB, any of the two combination of the three letters. Or if you see this lowercase n, I can also call it line N. Okay? So there's number 9. Or no, number 8. Number 9. What are two other names to name plane C? Well, plane C is this plane right here. So you can't use a capital letter because that's plane C. So that's the only capital letter. So now we have to use 3 of the 4 points that are on this plane. Now, the only exception is you can't use 3 collinear points. So E, B, and F, that collection of 3 points cannot be used. But we can use 2 of them. So plane E, B, G. Let me write the G better. G. So again, I use 2 of the 3 in the line, and then the one that's non-collinear, or plane, and I'll pick 2 other ones, B, F, and then G. So G had to be used because it's non-collinear with these 3 points. Okay, let's move on to 10. 10 says, name 3 collinear points. Well, we kind of just talked about it. It's the 3 points that are in a line. That would be E, B, and F. E, B, and F that are on line N. Okay, and then number 11, name 4 coplanar points. This is the plane, okay? You have E, B, F, and G. C is not a point. So E, B, F, and G. Now, say there was a point down here, okay? Say that point was, we'll call it point A. A is not on the plane, so it would be non-coplanar with those 4, okay? So if you have a point on this line is not resting on the plane, it's going through the plane. So A would not be on the plane. It would not be coplanar. Okay, so here's our next problem. Here we have this picture of 2 planes intersecting. And the question is, name the intersection of the 2 planes. Well, we have to know that the intersection of 2 planes is a line. So if I look at this picture, this line right here is the intersection of those 2 planes. And it extends infinitely because the planes extend infinitely. So we have 3 points on this line, X, S, and Y. We can name the line with any of those 2 points. X, Y. And there we go. I could have called it SX, I could have called it SY. Any of those 2 points would work. Okay, so here's our next problem. It gives us the lengths of 3 segments, RS, ST, and RT. It wants us to find the value of Y and then find the lengths of the 3 segments. Okay, so this is the picture. So why don't we first label our picture? So RS is 8Y plus 4. That's from here to there. ST is 4Y plus 8. And then the whole entire length, RT, is 15Y minus 9. And again, I just like the visual from the picture. Okay? So this is a segment addition problem for finding Y in RS, ST, and RT. So we look at this picture. RS plus ST equals RT. We set up that equation first. Then we do substitution. Okay? We have expressions for all 3 of these guys. RS is 8Y plus 4. ST is 4Y plus 8. And RT is 15Y minus 9. And now we need to combine like terms and solve this equation. So we can combine the 8Y and the 4Y and make 12Y. We can combine the plus 4 and the plus 8 and get plus 12. That's 15y minus 9. Let's move the 12s to the right side to keep them positive. So subtract 12y from both sides. 12 equals 3y minus 9. Let's add the 9 to both sides. And I'm going to scroll up here. So we get 21 equals 3y, and let's divide by 3. There's y. 7 is y. So now we need to do the second part, which is find RS, ST, and RT. So to find RS, we plug it in. RS is 8 times 7 plus 4. That is 56 plus 4, that's 60. ST is 4 times 7 plus 8. That's 28 plus 8, that's 36. And now RT is 15 times 7 minus 9. And in my calculator, 15 times 7, I think is 105. And 105 minus 9 is 96. And it's amazing, the magic of math, because these two smaller segments, RS and ST, 60 and 36, should add up to 96, the bigger one. And they do. So it's perfect. Okay? Segment, addition, postulate. Okay, so in this question here, we have to find PT, and we have information about PT and TQ, and we have this picture. Well, look at these congruence markings right here. What does this tell us? This tells us that segment PT is congruent to segment TQ, which also tells us that the length of PT is equal to the length of TQ. Okay, very important. So what this also means is that that T is the midpoint. So it gives us another piece of information. But we look at what we're given. We're given PT is 5x plus 3 and TQ is 7x minus 9. Make a substitution. PT is 5x plus 3. TQ is 7x minus 9. And now just move some things over. So move the 5x over. 3 equals 2x minus 9. Add the 9. 12 equals 2x, and divide by 2. And 6 is your value of x. Okay, but they don't want 6. They don't want x. They want PT. So PT is 5 times 6 plus 3. That is 30 plus 3, which is 33. Very, very good. Okay, so here's our next problem. We have two parts. And we'll call it part 22, because that's problem 22. It gives us the measure of angle ABD, and it's asking us what are the measures of angle ABC and DBC. Well, they give you the information about three angles, this one, and the large one. So this is an angle addition problem. So we add the two small ones, the measure of angle DBC plus the measure of angle, so DBC, CBA, equals the measure of angle ABD, the big one, or DBA, however you want to put it, okay? Remember, the outside letters don't matter, it's the vertex that matters. So DBC or CBD, CBA or ABC, ABD or DBA, doesn't matter. So DBC is this angle right here. That's the first one. That's 5x plus 4. CBA is this angle right here. That's 8x minus 3. And ABD is the big angle, 79. So now we just solve. 5x and 8x is 13x. 4 minus 3 is 1. Subtract 1. Divide by 13. X comes out to be 6. So there's x, but that's not what they wanted. They wanted the measure of angle ABC and DBC. So we plug it back in. The measure of angle ABC. ABC is 8 times 6 minus 3. That is 48 minus 3, which is 45 degrees. The measure of angle DBC, DBC is the angle on the left here, is 5 times x plus 4. That's 30 plus 4, that's 34 degrees. And the magic of mathematics, 34 and 45 is 79. Okay, I'm going to scroll down and I'll copy the picture again. Let's see if this works. Control V. Yes, it did. And we'll do 23 down here. Okay, so 23, in this problem it says angle RQT is a straight angle. Well, we need to know that if it's a straight angle, that means that it measures 180 degrees. So these two angles make up RQT, the straight angle. This is RQT. So those two angles make up the straight angle. That means we have a linear pair. Hopefully from your note cards you remember linear pair. And we should know that a linear pair are supplementary. And there's that 180 number, right? So it's all connected. So first I'll do the measure of angle TQS plus the measure of angle SQR equals 180, right? TQS is the left angle, SQR is the right angle. They add to make 180. So now we'll substitute. TQS says 6x plus 20. SQR says 2x plus 4. And that is 180. 6x and 2x is 8x. 20 and 4 is 24. That equals 180. Two steps. Subtract 24 and divide by 8. 19.5. But they don't want x, they want the measure of the two angles. So the measure of angle RQS is the one on the right here, 2 times x plus 4. That's 39 plus 4. That is 43 degrees. Notice I put degrees. The measure of angle TQS is 6 times 19.5 plus 20. That is 6 times 19.5 is 117, and add 20 is 137. And again, the magic of math, right? 137 and 43 is 180, which is that straight line. Beautiful. Beautiful. Couple more. Alright, so let's take a look at this problem here. Now we have all these different types of angles, okay? Remember, there's 5 types you have to remember. Adjacent, vertical, complementary, supplementary, and linear pairs. Let's see if we can identify some here. So number 7 saying, is each statement true? Explain. So, angle 1 and angle 5 are adjacent angles. Here's angle 1. And here's angle 5. They touch. So my initial thought is yes. Do they overlap? No. So the answer is, it is true, yes. They share a side, share a vertex, and no overlap. So yes, they are adjacent. And remember, adjacent means next to. Okay, adjacent means next to. Okay, 8. Angle 3 and angle 5 are vertical. So let's take a look. Angle 3 is right there. Angle 5 is right there. Notice this side and that side, they are not opposite rays. Remember the definition of vertical angles. Two angles whose sides form opposite rays. So this is no. Sides aren't opposite rays. If you notice, these two sides are, because they make a straight line, but the other two sides are not. Okay? Next, number 9. Angle 3 and angle 4 are complementary. So here's angle 3, and here's angle 4. They are adjacent, but complementary. Remember, complementary means 90 degrees. And here, these two angles make a straight line, so no. Do not create a right angle, right? When they have to create a right angle, since they're adjacent to each other to be 90, so they don't. They are actually, right, they're supplementary. So don't be confused there. All right? Let's do number 10. Angle 1 and angle 2 are supplementary. This book is great because they try to fool you. Angle 1 is here. Angle 2 is there. They are adjacent, but look, I've kind of erased it by now. That right angle box right there. They're not supplementary. Supplementary means 180. So, no. because they do not create a line, right? They're adjacent, so they'd have to create a line. These two are actually complementary. So they should have taken these two guys and switched them, right? If they would switch 9 and 10, then they would have both been true. Okay, so hopefully we can identify the different types of angles. Very important. Okay, here's our last problem for the evening. And again, hopefully you feel like this helps you, and you'll do very well in class on the quiz. So it says ray BD bisects angle ABC. So stop there. Draw angle A, B, C, and have a ray BD bisecting it. So what that means is this angle is congruent to that angle. Angle ABD is congruent to angle DBC, which means that the measure of angle ABD is equal to the measure of angle DBC. And I want you to solve for x and find the measure of angle ABC. Well, they give you information about these two angles. ABD is 3x plus 20. Plug it in. DBC, or CBD, right? Same thing. CBD is 6x minus 16. Plug it in. And now solve. Subtract 3x. 20 equals 3x minus 16. Add 16. 36 equals 3x. The 16's cancel. Divide by 3. And there is the value of x, 12. So now they want the measure of angle ABC. That's the big angle, and I don't know anything about that. But I do know that the two smaller angles add up to make the big angle, and the two smaller angles are the same. So let's first find the measure of one of them. Let's find the measure of angle ABD. 3 times 12 plus 20. That is 36 and 20, that's 56 degrees. So I know that the measure of angle ABC is 2 times 56, or 56 plus 56. So the measure of angle ABC is 112 degrees. And that's the other answer. Okay, so again, hopefully you felt this video helped. Hopefully you copied the answers down, or did the notes, did the problems with me, so you can bring them in for bonus on Thursday or Monday. And we'll see you in class. Happy studying.